Every wooden structure you see today is already on a timer. Decks rot, fences collapse, support beams weaken from the inside out, and within 15 to 30 years, most untreated wood begins to fail, even when it looks perfectly fine on the surface. Meanwhile, structures treated with a mineral compound discovered thousands of years ago are still standing after a century, sometimes longer, with minimal decay and no structural compromise. And by the end of this video, you will understand exactly how this process works, why it quietly disappeared from mainstream construction, and how the same chemistry is still being used today, just not in a way that benefits you. To understand what was lost, we need to go back long before modern lumberyards, before pressure-treated wood, and before the idea that materials should be replaced every few decades. In ancient China, builders used natural mineral salts to preserve wooden temples exposed to humidity, insects, and seasonal flooding. Some of those structures are still standing today, not because of luck, but because the wood itself was chemically altered to resist decay at a molecular level. In Scandinavia, Viking-era timber structures were treated with mineral-rich solutions and natural oils that prevented fungal growth and insect damage in climates where untreated wood would not survive even a fraction of that time. And in medieval Europe, boron-based compounds were used to protect beams in cathedrals and homes, particularly in regions where moisture and wood decay were constant threats. These builders had no synthetic preservatives, no industrial pressure treatment plants, and no modern coatings. What they had was a deep understanding of how certain minerals interact with organic material and how to use that interaction to make wood fundamentally inhospitable to the organisms that destroy it. That same principle still exists today, and it centers around a simple compound most people have seen but never considered for construction use: boron. More specifically, borate compounds. When dissolved in water and applied to wood, borates penetrate into the fibers and remain there as a long-term protective agent. Unlike surface coatings, which sit on top of the material and eventually crack or wear away, borates become part of the wood itself, and what they do once inside is what makes them so effective. Fungi, the organisms responsible for wood rot, rely on enzymes to break down cellulose and lignin, the structural components of wood. Boron interferes directly with those enzymatic processes, disrupting the organism's ability to metabolize the material. At the same time, borates inhibit spore germination, so the fungus cannot even begin to colonize the surface. Insects, including termites and carpenter ants, are also affected. When they ingest borate-treated wood, it disrupts their digestive systems and prevents them from extracting nutrients. Over time, entire colonies collapse. The United States Department of Agriculture has been studying borate wood preservation for decades. Their research shows that properly treated wood can resist fungal decay and insect damage for decades, even in high moisture environments. In controlled conditions, borate-treated wood has demonstrated lifespans exceeding 50 to 100 years without structural degradation. Now compare that to modern untreated lumber, which can begin to show signs of rot within 5 to 10 years when exposed to moisture. Even pressure-treated wood, which uses chemical preservatives forced into the material under high pressure, often begins to degrade after 20 to 30 years depending on conditions. The difference is not subtle. It is fundamental. So if this method is cheaper, simpler, and proven over centuries, why is it not standard practice for every piece of wood used in construction today? The answer, as always, becomes clear when you follow the economics. The global wood preservation market generates billions of dollars annually, driven by products designed to extend lifespan, but not eliminate replacement cycles entirely. Pressure-treated lumber, stains, sealants, and coatings all share one common characteristic: they degrade over time. They require reapplication. They create recurring demand. Borate treatments, when applied correctly and protected from direct water exposure, can last indefinitely inside the wood. There is no recurring sale. There is no replacement cycle. there is no long-term revenue stream, and that makes it fundamentally incompatible with an industry built on continuous consumption. Building codes add another layer to this. While borate-based products are approved and used in specific applications for termite prevention, they are rarely mandated or even mentioned as a standard preventive measure for general wood construction. The International Residential Code includes extensive sections on moisture barriers, ventilation, and treated lumber, but it provides no widespread requirement for borate treatment in standard framing. Contractors follow code. Inspectors enforce code. Anything outside that system is treated as optional, unfamiliar, or unnecessary. At the same time, most construction training programs focus on modern materials and systems, not traditional preservation techniques. Builders are taught how to install pressure-treated wood. They are not taught why older methods often outperformed it. So the knowledge fades, not because it stopped working, but because it stopped being taught. But the physics and chemistry have not changed. Boron still disrupts fungal metabolism. It still prevents insect damage, and it still costs a fraction of what modern preservation systems require. A typical borax-based solution can be mixed using 1 cup of borax per gallon of hot water. The powder dissolves, creating an alkaline solution that can be applied with a brush or sprayer. For structural wood, such as beams, joists, and subflooring, this creates a protective layer that penetrates into the material and remains there as long as the wood stays dry. For outdoor applications, additional protection is needed to prevent the borate from washing out. This can be achieved with simple sealants or by designing structures that minimize direct water exposure. That distinction is critical. Borates are highly effective, but they are water-soluble. They protect dry wood exceptionally well. They are not designed to withstand constant saturation. This means the system works best when combined with proper design, overhangs, drainage, airflow, and moisture control. The same principles ancient builders relied on. And when those principles are applied correctly, the results are not incremental. They are transformative. Wood that would normally decay in decades can last generations. Structures that require constant maintenance become nearly static, and the cost difference is almost negligible. A box of borax costs a few dollars. The application takes hours, not days, and the long-term savings can reach thousands over the lifespan of a structure. So why does almost no one talk about it? Because it solves a problem too well, because it reduces the need for replacement, because it shifts the model from consumption to durability, and because once you understand it, you start to see the pattern everywhere. Technologies that last are rarely the ones being promoted. Solutions that eliminate recurring costs are rarely the ones being taught. And knowledge that empowers independence is rarely the knowledge that scales profit. But the material is still there. The chemistry is still understood. And the method is still accessible. Which means the only real barrier is awareness. Because once you know that a simple mineral can extend the life of wood by decades, sometimes even a century, the way you look at every structure changes. The deck in your backyard, the framing in your walls, the beams above your head, all of it operating on a timeline that could have been extended, all of it subject to a process that has existed for thousands of years. And all of it still within your control. The wood has not changed. The organisms that destroy it have not changed. The chemistry that prevents it has not changed. Only the knowledge has. And now you have it.